Phil is going to help us out this time. Oh, and Kuti. There's Kuti. She's a little crazy. All right. Well, there's cats all over the place. We're going to do this. So what we're summarizing, what we've done so far. 1 second. These chords organized. Come on, chords, be organized. There. All right. Oh, and probably turn. All right, now I'm ready to actually get the show on the road. Okay, so this is from page 194, number 24. Guess what? This is where your homework's going to come from. So here's number 24 right there. It says y equals 1 over x squared minus 1. And it says find the extreme values of the function where they occur. This time there is no interval. So that again plays into what I wanted to start with, is finding these maximum values for the whole real line. And then we'll deal with intervals next. Okay, so our job is to do this. These are really our steps for this. It's just find all the critical points, every place where f prime of x is either 0 or undefined, and then use the first derivative test to determine which of these points are maximum and which are minimum. All right, so it starts by, to find all the critical points, it starts by finding the derivative. So y prime, so let me say something about finding this derivative. So do you think we need quotient rule to do this? So a lot of people would start using quotient rule because it looks like a quotient, but if you think about it, because the numerator is just a constant, it will be much easier to rewrite y as x squared minus 1 to the negative 1 power, and then use the chain rule. So that will be much easier. So y prime is equal to negative 1 times x squared minus 1 to the negative 2 power, and then times the derivative of the inside function, which is 2x. Now, if you use quotient rule, you'll get something actually more complicated than that, and you'll then have to simplify it. So this is definitely the easiest way to do it. However, we do want to write this as a fraction. So one important thing when we're trying to set up for this first derivative test or finding the critical points, we need to write the derivative as a fraction like this. Okay, and then the next thing you want to do is make sure that your denominator is fully factored. Okay, so in fact, the denominator we can factor. So this equals negative 2x over x plus 1, x minus 1 squared. Right. Now, you can get the result that I get if you really understand this, how to make this denominator 0. You don't have to write this like this, but that's a good way to do it. Okay, so then what you want to look at once you get the derivative fully factored and in a fractional form is there's two things you're looking at, is where f prime of x equals 0 and where f prime of x is undefined. You want to look for both of those things. How do I know where that happens? When I have a fraction, f prime of x equals 0 whenever just the numerator is equal to 0. We could consider the negative sign as belonging to the numerator or the denominator. It doesn't matter. All right. F prime of x is undefined where the denominator equals 0. So this is numerator equals 0. I actually meant to write that, but for f prime of x undefined, we're going to say where the denominator equals 0. So that's where x plus 1, x minus 1 squared equals 0. Okay, so the numerator equals 0 gives us x equals 0. That's where f prime of x is undefined. And the denominator, I can see that this is only going to be 0 if either x equals 1 or x equals negative 1. So what I meant before about that you don't necessarily have to factor this is if you can look at this denominator and say, oh, I can see that that denominator is going to be 0 whenever x squared minus 1 equals 0. So that's when x equals 1 or x equals negative 1. Right? There's other ways you can go through and do that, but that's what we get either way. All right, now, here's something you have to watch out for, and you need to watch for it as soon as you get your critical points, especially the undefined ones. Are they in the domain of the function? X equals 1 and x equals negative 1. We already know they make the denominator of f prime 0, but do they make the denominator of f 0 as well? They do. Therefore, x equals 1 and x equals negative 1 are not critical points because they are not in the domain of y. All right, so we knew they weren't in the domain of y prime, but they're also not in the domain of y, and for that reason we're going to throw them out. So your f prime of undefined is only going to be a critical point if what you get is not in the domain of y prime, but it is in the domain of y. So that's what we'll see more examples of that going forward. All right, so the result of that is that these two guys are out. Now on the AP exam, a lot of times, by the way, they will give you points for considering all the possibilities and then giving a specific reason for excluding one of them. So if you're going to exclude certain values, you can't just have forgotten about them. All right, you have to show that I know those values are potential critical points, but they're not in the domain, so I'm throwing it out. So the result of that is our only critical point is x equals 0, this one. All right, now we'll see what to do with the critical point next.